of thalamus. All right, guys? I think it's easy because we already explained them previously in more details. Now, what is the idea of the hypothalamus? It's very simple. Like we said, hypothalamus is more or less medially and laterally somehow like the thalamus. Remember that the thalamus, the hypothalamus is down here. So what is on top of you is the thalamus. So it's not written here. It's common sense that thalamus is on top of you. And anteriorly, the hypothalamus is limited by the lamina terminalis, which is that group of axons coming down from the anterior commissure to the optic chiasma. So this is the lamina terminalis. It's anteriorly. It's limiting your hypothalamus anteriorly. And what is medial to you, like the thalamus, is the third ventricle. And what is inferior to you is very easy. And you guys know that from the endocrine module, that it's stuff related to the pituitary. So because you guys know that the hypothalamus is so much related to the pituitary. So what you have down to you is, first of all, you have the mammillary bodies. You have the mammillary bodies down to the hypothalamus. And also you have stuff related to the pituitary, which is the tuber cinereum. It's the elevation from which you will get the infundibulum, which is what holds the axons coming from the hypothalamic nuclei that releases two types of hormones from hypothalamic nuclei, and you store them in the posterior pituitary, all right, and then you release them, all right, and that is already explained in the endocrine module related to the pituitary gland function. All right, and you also have the inferior perforated substance. All right, so inferior to the hypothalamus, you have the mammillary bodies, you have the tuber cinereum, which is the elevation that is below you, and from that you will get the stalk for the infundibulum, which holds the hypophysis or your pituitary gland. It's gonna hold it into it, and that is all related to the pituitary. All right, guys? Now, how can we remember the hypothalamic nuclei as a basic function? Like I said, you guys, we have two nuclei, and these nuclei are related to the pituitary gland. From here, you have the oxytocin hormone from the paraventricular nucleus, and from the supraoptic, you have the ADH. And these hormones, you get them, I colored them in green because they are related to the pituitary gland. So from here, you form the hormones and you take them by those axons and you store them in posterior pituitary so that you are ready to release them when needed. Okay, so these two are already discussed, or already you guys studied them already in the endocrine module, and I'm sure that you guys know the function of them. Now then we have the anterior and posterior nuclei of hypothalamus. Both of them are related to thermoregulation. So anterior to you and posterior, you are all surrounded by heat. Okay, I'm trying to give you just hints to help you remember the function in the exam. So anterior and posterior to you, you are surrounded by heat, and you need to thermal regulate that. Whether it's conservation of the heat or dissipation of the heat. All right, so anterior and posterior nuclei is for thermal regulation. Another thing, they are related to parasympathetic and sympathetic. Which one is for which? Of course, what is anterior to us, what we want is to relax, rest, and digest. So what everyone wants to face all the time is the rest and digest. So parasympathetic is by anterior nucleus of thalamus. And what no one wants is to sympathetic innervation, fight or flight. No one likes fight. No one likes flight. So you would like to keep this nucleus behind you. So the posterior nucleus is for sympathetic, anterior nucleus parasympathetic. Now, how will you remember the function of the pre-optic? Pre looks like puberty, so it's sexual stuff. So it contains sexual nuclei, and it regulates the release of gonadotropic hormones. All right, so pre-optic, it looks like puberty, so you can remember that this is the function, and it lies pre to the optic chiasma, so that's why we call it pre-optic nucleus. All right, and then you have the suprachiasmatic. All right, so the suprachiasmatic, you guys know that these are the optic nerves. They would form the optic chiasma and then tracts. So it's kind of something, looks like half of a circle, and the circadian rhythm is a circle, so that you can remember that the suprachiasmatic nucleus is responsible for controlling the circadian rhythm, and it's related to receiving inputs from the retina regarding the light and that would control your circadian rhythm. And what else do you need to remember? The mammillary body, of course, everyone knows that it's related to the limbic system. And the last two nuclei is the medial and lateral nuclei. Lateral nucleus is just lateral nucleus. Medial nuclei, you have dorsomedial and you have ventromedial. So when we said that anterior and posterior surrounded by heat, one sympathetic, which is what you don't want, you will push it behind your back. One parasympathetic, it's what you want, which is anterior to you. We also have a story here with the medial and lateral nuclei related to food. Do you want to eat? No, everyone wants to get thin, unless you are so thin already, all right? But most of the people, they don't want to eat, they don't want to gain weight. So you would want to have your lateral nucleus responsible for eating. So you would want to keep your food away from you, lateral nucleus. So the lateral nucleus stimulation induces eating. However, the dorsomedial nucleus and ventromedial nucleus, they are also responsible for eating, but what you want to keep in front of you, medial to you, you want to hug the satiety center because you don't want to increase weight. So you would want to hug. How would you hug a nucleus? You will bring it in front of you and medial to you. All right, so this is the satiety center. And the dorsomedial nucleus, it's also related to obesity. All right, so stimulation to that will cause obesity. So the dorsomedial, yes, it's medial, but it's dorso, so it's posterior. You don't want it because you don't want to become obese. All right, so lateral nucleus, it induces eating, so it's lateral to you. Dorsomedial, it stimulation increases obesity, so you don't want it. So you want the ventromedial one. So it's all about food people. The only one you will hug is the satiety center because you don't want to gain weight. And the other people you will put behind you, dorso and lateral, it's gonna be the people related to eating and obesity. All right, guys, by that, this will help you to remember the basic function of the hypothalamic nuclei. And this is just a nice picture that would help you in a practical session. If you look at mid-sagittal section at the center of your brain, you know that this is the thalamus, and you have the interthalamic adhesion, and you have the hypothalamic sulcus that separates the thalamus from the hypothalamus. In front of your hypothalamus is the lamina terminalis. Below you is the elevation that is the tuberosinium, and from here you have the infundibulum that holds your pituitary. So these are all inferior relations. Medial relation would be the lateral ventricle, remember, for both of them. All right, lateral relation would be the internal capsule for both of them, and for the thalamus you also have the lentiform nucleus and caudate. All right, superior relation to the hypothalamus would be thalamus. Superior relation to the thalamus itself would be the body of lateral ventricle, the choroid plexus that forms it, and also the fornix that surrounds you and separates you from the lateral ventricle. All right, so this is just a recap for the structures related to that. And also below you have the mammillary body for the hypothalamus. So we said we have 4 structures. We have the tuberosinium and the infundibulum coming out of it. We said we have the mammillary body and we have the inferior perforated substance. So this is the inferior relation. And now we made a recap for all of the relations, and here this is a coronal section to show you the thalamic nucleus in the center. Again, we have superior to you the body of lateral ventricle, and you have your fornix superior to you, and you have the choroid plexus that forms the CSF superior to you. This is superior relation of the thalamus. Lateral relation of the thalamus, superior would be the caudate nucleus and inferior would be the lentiform, and separating you from these guys is the internal capsule. And also you have the hypothalamus. Lateral to you is going to be the internal capsule, medial to you, and medial to the thalamus would be the third ventricle. All right, below the thalamus is going to be the hypothalamus and subthalamus. The subthalamic nucleus, like we said, it's that structure that is related to the basal nuclei function. So it has 3 nuclei. One is part of the red nucleus, one is part of the substantia nigra, and one is the subthalamic nucleus. And it also has tracts, which is basically because the subthalamus is continuation of the tegmentum of midbrain. So if I have lemnisci coming up through the tegmentum, it needs to go through the subthalamus. So it's part of it. So the tracts would be the medial lemniscus, spinal lemniscus, trigeminal lemniscus, right? So this is the subthalamic nucleus. And I think we recapped all the medial relations, lateral relations, superior relations, inferior relations of the important people in the diencephalon. Thank you guys for watching. I hope you found it easy, and I hope you grasped the relations, nuclei, and the basic functions of parts of the diencephalon. Thank you, and see you in the next videos.